Hello guys, welcome back to your favorite YouTube channel, Master Your Studies. So our question of today reads, a uniform ladder AB of length 2A rests in limiting equilibrium with its top end against a rough vertical wall and its lower end on a rough horizontal floor. The forces acting on the ladder are shown in figure 1. This is our figure 1. So we have been asked to find the angle theta which AB makes with the floor. Okay, so let's start by analyzing our system. Okay, so we have been told that the vertical wall is rough and the floor is also rough, so meaning there is friction at those points. So this upward force 8 Newton is the friction force produced between the ladder and the vertical wall, and this horizontal force 9 Newton is the normal force produced by the ladder and the vertical wall. We have the weight of the ladder acting at its midpoint. You can see how it is pointing vertically downward. Okay, so we also have the 32 Newton force acting vertically upward, which is simply the normal reaction force between the ladder and the floor. Then finally we have the friction force produced between the ladder and the force, which has value 9 Newton. Okay, so we have also been told that the system is in equilibrium. Okay, so let us recall this concept. Okay, for a body in equilibrium, we have three conditions. That is, the sum of horizontal forces should be 0, the sum of vertical forces should be 0, and the sum of moment about any point should be 0. Okay, let me put it here. Now we are going to test each condition to see if our system actually satisfies them. Okay, so let us start with the sum of horizontal forces. Okay, let me pull this. Okay, so actually horizontal forces are forces that either go to the right or goes to the left. That is, here we are going to consider forces going to the right as positive and forces going to the left as negative. So let us identify those forces in our system. Okay, so we have this force and we have this other force. Okay, so and we also have to consider their direction. So we have the 9 Newton force, this force going to the right, which is positive, and we have this other 9 Newton going to the left to be negative, and their sum should be 0. Okay, so this first condition has been satisfied. Okay, now let us check the second condition, vertical forces. Okay, so vertical forces are forces going upward or downward, and here we're gonna consider upward forces to be positive and downward forces to be negative. Okay, so let's highlight those forces. We have this force, we have this other force, and we have this force. Okay, so our first force 8 Newton should be positive, the second force 40 Newton should be negative. Then our last force 32 Newton, which is also positive, and the sum of these forces should give us 0. Okay, so our second condition is satisfied. Okay, just put it here. Okay, then our last condition is to check the sum of moment about any point. Okay, let us recall first what is moment or moment of a force. So basically, the moment of a force is the turning effect produced by that force acting on an object about a pivot. And mathematically, this can be represented by this formula: moment m equals to force times perpendicular distance from the pivot to the line of action of the force. So it's very important to know that it is the product of the force times the perpendicular distance to the line of action of the force. Okay, so just put this formula here. Let us quickly take a simple example to understand moment. Okay, if we use this example, so let us imagine a door that rotates about its hinges. So these are the hinges of the door, or we can call them our pivot. So our door rotating as it hinges, and if you apply a push here at the handle of the door, we can see that the force will produce a turning effect, which is our moment. Okay, so what will happen if we apply a force on our pivot that is directly on the hinges? And you might have guessed it, no effect, no turning effect will be produced. That is simply the moment produced here will be 0. Okay, let us bring another diagram. Is illustrating what we have just said. Okay, so still with this our force, this one, we can see that this force is perpendicular to a distance d from the pivot, this violet line, from the pivot to the line of action of our force, satisfying the condition of moment, that is the force times the perpendicular distance from the pivot to the line of action of the force. And we see that for the force directly applied at our pivot, the perpendicular distance is simply 0, making our moment to be 0. That is producing no turning effect. So what we can consider here is that for us to produce a greater moment, the force should be applied at a distance from the pivot, and if the force is applied directly at the pivot, the resulting moment will be 0. Okay, so let me just put this one here. Okay, so the sum of moment about any point should be 0. Okay, so here we have two options. We can take our moment about point A or about point B, but since our question is asking us to find the angle theta, it will be easier for us to take our moment about point A. So here it will be sum of moment about point A. Okay, so if we take the moment about this point A, change the color, we see that the force is directly acting on this pivot point will be 0, as we just saw from our other example. So this 32 newton will result in 0 moment, so we can remove it. And similarly, this 9 newton will result in 0 moment because their line of action passes through the pivot. So we have just demonstrated that. So this force is 0. Okay, so now we see that we are just left with three forces, these three forces. So we gonna find their perpendicular distance from the pivot to their line of action. Okay, let us start with this 8th Newton force. Let us see its line of action. Okay, we draw its line of action. Okay, so this is the line of action of this 8 Newton force. So the perpendicular distance from our pivot to this line of action will simply be this distance. Okay, let us draw this, the distance, or perpendicular distance. Okay, so this is what we need to find. You can call it x. This distance, call it x. Okay, we can see that we have a right angle triangle with this side being the opposite, this side being our hypotenuse, and this missing side is our adjacent. Okay, so from trigonometric rule we can find our adjacent provided that we have the hypotenuse, and the hypotenuse here is simply 2a, which is the length of our ladder. So using cos, theta equals to adjacent x all over hypotenuse 2a, we have x equals to 2a cos theta. Just copy it and paste it here. So this side x is 2a cos theta. Okay, so this simply means for the 8 Newton force, the perpendicular distance is 2a cos theta. Just put it here, 2a cos theta. Okay, now let us look the perpendicular distance of this 9 Newton force. Okay, as similar to what we did in for the 8 Newton force, we are going to draw the perpendicular distance. Sorry, we are going to draw the line of action of this 9 Newton force. Okay, we draw this. This is our line of action. Extend it a little bit. So the perpendicular distance from our pivot to this line of action should simply be this distance. Okay, So this should be our perpendicular distance. And similarly, we can see that we have a right angle triangle form where this side should be similar to this side. So we can just duplicate this line to this side. Okay, so for us to consider this triangle, and our missing side is this x opposite. So from sine theta equals to opposite x all over hypotenuse 2a, we have x should be equals to 2a sine theta. Okay, so this side should be 2a sine theta side here. Okay, so the perpendicular distance of this 9 Newton force is 2a sine theta. Just put it here. Okay, then finally let us find the perpendicular distance of this 40 Newton force, which is simply the weight of our ladder. Okay, drawing our line of action. You might have guessed it, the perpendicular distance will be here from the pivot to the line of action of the force. Okay, so this is our perpendicular distance. Okay, so we have this small right angle triangle where our hypotenuse here is a and our missing side is this x, which is our adjacent. So using cos theta equals to adjacent, which is x, all over our hypotenuse, which is a. So x should be equals to a cos theta. So this side should be a cos theta. Okay, so the perpendicular distance of the 40 Newton is a cos theta. Okay, you can just get rid of this. Then one thing that we can also have to consider is the direction of our movement, whether it is going in clockwise direction or anti-clockwise direction. Okay, so let us analyze the moment produced by this 8 Newton force. We can see that this 8 Newton will make our ladder to go in a clockwise direction, like this direction, clockwise. Okay, similarly this 9 Newton will make our moment to go in a clockwise direction, and clockwise direction here should be positive. Then with this 40 Newton, if we analyze direction, it will make our ladder to go in anti-clockwise. That is, our ladder will try to turn anti-clockwise like this, negative. Okay, so from this our formula, sum of moment about point A should be equals to 0. We will have this, okay. So if we simplify, we have this 8 sine theta equals to 24 cos theta. Then finally we have tan theta equals to 4 on 3, and our angle theta is simply the tan inverse of 4 on 3. So I hope you have enjoyed this video. So please hit the like button, subscribe, and yeah, let's see you next.